Hello and welcome everybody to the day 7 of our Smart 25 Days Challenge. And today we are going to create a very basic smart contract, which is going to be a time delaying smart contract. So, what is it? It would be implementation in which we are going to introduce a delay before some specific action is being performed. So, this is a very basic smart contract what we are going to create today, but it is very important for the upcoming videos, which in which we'll see how this smart contract will help us, and we'll also see how time delaying is a requirement in many use cases. And we you can see that it can be thought of like well, while creating a crowdfunding platform, and that also we may require to introduce some delay is what we need, want to create some deadline kind of thing, which will help us to will allow the users to perform some specific action, yeah, only when a specific time has been reached. So this can be in case of deadline, we want that the user or the fundraiser who has created this crowdfunding campaign should not be able to withdraw its funds before the campaign is over. Or we may think of we can even create a, a simulation of a bank in which we'll allow the users to deposit their funds, and we can think of that like a fixed deposit type of thing. And in that, we will only allow the users after some specific period has been after some specific period has passed, and only after that we will allow the depositors to withdraw their funds. So we can think of it like that. In the advanced versions in the upcoming videos, we'll see how this smart contract can be upgraded. For today, we are just going to stick with the basic implementation. And what that would be, we are going to create some only two three functions where one would allow the user to deposit some funds, and that same user, that user, only one user, it is just for a single user, that would be declared the owner, and that owner only can withdraw those funds after some specific period has passed. So that's what we are going to create today. So let us get started. So first of all, we'll create a smart file, and we'll name it time delay. That's all. Then our first line is always the SPDX comment, as you all would be knowing. So now let us start defining our smart contract. uh, and delay. Inside it, now let us declare our state variables, which would be the first of all, we want to create the owner, and that would be addressed so that we may know who is the owner or who has deployed this contract. And then we'll allow only that person to withdraw its funds. And we'll also keep track of the release time. What would be the release time? Uh, Only after that time we'll allow the owner to uh, to withdraw its funds. Then we'll are also creating a state variable to keep track of the account balance. Okay. Now let us make a constructor. And what is a constructor? Constructor is a special function which gets executed only one time while the deployment of the smart contract. Okay, so let us define it. We just need to make sure that the owner, we are setting up the owner, and that owner is message.sender. Okay, so the person who deploys this smart contract becomes the owner. This constructor. Okay. Now let us define our functions. The functions would be, one is to deposit the funds, and here only we'll introduce the delay. We'll ask the person how much delay you want, and that would be in seconds. Like after how much seconds you want that you should be able to withdraw your funds. So and this function should be public and payable. And here we are specifying the requirements, and the required conditions should be that the message dot value should be greater than 0. Otherwise it should say that no amount sent. Now for the account balance, what we'll do, we'll increase the account balance with message dot value. And here we are now setting up the release time. That would be block dot timestamp. I've told you what this block dot timestamp is. So I've told you in the earlier videos, previous videos, and now we are adding the delay with it. So that's it for the deposit function. Then now let us create the function that is to withdraw. So while withdrawing, we want some conditions to match, and these are, first of all, the person calling this withdraw function should be the owner only. Owner. And otherwise we'll say that only the owner can call this function. The can withdraw funds. That's it for our first required condition. The second required condition would be, we want that the owner should not be able to withdraw the funds before the specific time has passed. So for that, we will keep a check that block that timestamp should be greater or equal to the release time. So block message sorry block dot timestamp should be greater than or equal to release time. Otherwise, we'll say that the release time has not yet arrived. Now, let us move on to the. We also want to keep a check that the funds, the account balance should be greater than 0. Otherwise, it should show an error. Otherwise, we'll show that no funds to withdraw. all these conditions are uh, true, so that it means that the checks, the caller of this function passes these checks. We'll move on to something which is that we want to transfer the amount to his account. So we want that the owner of this contract, which should be the caller in this case, should be able to withdraw its funds after the specific amount or specific time period has passed, and the account balance should be greater than zero, which is pretty obvious. Message dot sender, and then transfer account balance. I have told you in my previous videos what this does and how it works. So if you have any confusion what is happening here, then please watch my previous videos. And now we are updating the account balance. After this, we just want to make one more function that would allow the user to see how much time is left before he can withdraw its funds. So let us create that too. Function get time left, and this function is public only view function, and it returns 46. That is the seconds. And if we are keeping a check that if block dot timestamp is greater than equal to release time, so then we'll say that there is 0 seconds left before the user can call the withdraw function kind of function. And now just print 0, and otherwise in the else case we'll say return release time minus block dot timestamp. I guess it's now complete. And what it means is block dot timestamp. I have told you before also. This is a standard time, and this block dot timestamp is the timestamp of the where at the moment when the user calls this get time left function. So say uh, if the block dot timestamp has passed the release time, so it should show that yes, now the specific amount of time has passed, and the user should be able to call the function withdraw function immediately. So we are returning 0, which means that now 0 seconds are remaining and you can call this withdraw function. For knowing in more detail what block.timestamp is, you can watch my previous videos. And in brief terms, block.timestamp is just a unique Unix epoch timestamp, and that epoch time is calculated. This is in seconds, and this time is calculated and gets updated from this date. This what is epoch time? The Unix epoch time is the number of seconds that have elapsed since January 1st, 1970. So this is the standard time which we use in Solidity for knowing at the specific time what when the function called this say get time left function. So what was the time at that moment? So this block dot timestamp returns this value, and it keeps updating every single second. See, you can see it is getting updated every single second. So that's what log.timestamp is. And now let us compile our smart contract and let us deploy it. So now we are able to deploy it and say the owner of the smart contract now wants to deposit some funds, and that function that funds would be, say, in some ether. Say he wants to deposit 2 ethers. So now in this delay he will specify how after how many seconds he wants to withdraw those funds, and we can say, let's say 20 seconds. Let us deposit it. Now we'll see the release time. This is the Unix epoch time. Okay, block dot at the specific time at which we would be able to withdraw these funds. And if we'll see the get time left, it's 5 seconds now, 3 seconds, and 2 seconds, and you can see 0 seconds. So now we can withdraw. The owner can withdraw these funds. See. So let us try again with trying to deposit some at least let's say 5 ethers, and after for 20 seconds, and let us try to withdraw it now only. Let us see what happens. It will show the error release time has not yet arrived. So, and we can even know how much seconds are left. So account balance is 5 ethers as of now. So now we can withdraw. That's it for today, guys, and I hope to see you again on the day 8 of our Smart 25 Days Challenge. I hope you like the video, and we'll see the implementation of this time delay smart contract in our further smart contracts, and we'll see the advanced versions of it. One more thing which I would like to mention here is I would like to ask you guys, just tell me, was this state variable required, this account balance? Please comment down in the comments. And I'm asking about this specific implementation. So, was it required to declare here's the account balance and this state variable, or we could have followed a different approach for sending the amount to the owner's address? So just tell me in the comments, and see you guys. Thank you for watching. Bye bye.